So who is new here for first time? Who is joining first time? Guys, Sherwin, are you joining first time this meeting? All right, guys. I'm going to start with the questions. It's already uh, time is getting out. So, hi Gurvinder, bro. How are you doing? Now I am recognizing you. You are dot there. Okay. Uh, let's wait 1 minute more, then we'll go start. Hi Ashish, bro. How are you?
Hi. Hi, I'm good.
Nice to hear.
आवाज आ रहा है ना?
Yeah, your voice is so clear, and you are looking
हाँ,
so
ठीक है.
handsome.
I know.
Uh, yeah, Sherwin, are you? Do you want to say something? Yeah, Kamlesh, bro, has also come. Yeah, nice to see you. Kamlesh, brother, all good? You are speaking, but your voice is not reaching to us. If you are hearing our voice. Kiran has also come. All right. I think 9 guys we are having. So I think we should start discussion. Okay. So today's electrical discussion, and I've already sent the questions list of questions. So I am going to start with the questions, and then we'll discuss about that question with cross questions and all. Okay. So the first question was yes, yes. So the first basic electrical question was explain Ohm's law in detail. Who'd like to go first?
So can you repeat once more? Hello
Explain.
again.
Yeah. I am repeating it here. Explain Ohm's law.
So can I say?
Yeah, sure.
Hello.
Yeah, go ahead. Sorry, your voice is not coming. Somnath, bro.
Yes. Some
Your
network issues there. So Ohm's law stated that. Hello.
Yes, go ahead.
Are you listening? Can you hear me?
Yeah, now I can hear you.
Hello.
Yeah, now I
Okay.
can hear you.
So Ohm's. Okay. So Ohm's law stated that the potential difference between 2 points in a closed path is directly proportional to current, which is flows in this closed path. So mathematically, V is directly proportional to I. So, and V is equal to IR. V is the voltage or potential difference, and I is current. Unit is ampere, and R is resistance, and its unit is ohm. That is Ohm's law.
Ohm's law is also valid when temperature changes. It's my cross question. Does Ohm's law valid if temperature changes?
Yes, it will be valid.
You are wrong, bro.
The resistance will for any conductor, the resistance will increase with temperature. No, it will
Ohm's law.
decrease with temperature.
See, Ohm's law states at constant temperature, defined as constant temperature only. Okay, I think let's start with another one. Any else would like to answer this question? Just like if you have been asked in interview, how would have answered? How would have you people answered this? Kamlesh, bro, would you like to go? Yeah, Ashish, bro, go ahead.
In Ohm's law states that current flowing through a conductor is directly proportional to the potential difference between them. That's the law, and I I don't know the validity when.
Okay.
That's it.
That's it. Do you know any application of Ohm's law?
Uh, in current flowing through where means like anywhere like
Does semiconductor follow Ohm's law?
no, I guess.
Why not? You are right, but why not?
It no, I don't have any idea.
No problem, no problem. Anyone else would like to answer?
Yes, I just so as everyone said, voltage is directly proportional to current in closed circuit, but you have to mention resistance, which is proportionality constant in that equation. Okay, so that is called as resistance, and resistance is proportional to the temperature, or like dependent on the temperature, decreases or decreases as per the temperature, increases or decreases. In case of semiconductors, semiconductors are special, like sort of they for some temperatures they work as conductor, and for some temperatures they work as insulators. So up to certain extent they do follow the Ohm's law, but as we know that Ohm's law changes its proportionality as per the temperature. So that's why it's not perfectly applicable for the semiconductors. Right? That's what I think.
Okay. If I have to ask to you, when does Ohm's law fail? In what type of materials?
I don't really have an idea, but
Just you
Ohm's
said,
law will
just you said
in
Ohm's law will
semiconductors.
fail.
in semiconductors, non-ohmic conductors.
Yeah,
Yeah. In diodes,
yeah.
Ohm's law
But
fails.
another thing I would like to mention is,
Mm.
let's say you have any conductor and you're changing the temperature. Like let's say you are increasing, the resistance will increase, and the relationship between the voltage and current will change.
Okay. Whenever we talk about Ohm's law, now we consider temperature as constant. Then after we talk about other
Yes.
things. Okay. So in semiconductor, because semiconducting device are non-linear devices. What I have read today, these devices are non-linear devices, means the current only flows in one direction, and the ratio of voltage to current is not constant for variation in voltage. Okay, v by I is not constant, v by I should be constant now, that is proper r, but it's not constant in semiconductor, as
R is
uh,
constant and V and I are directly proportional.
v I v v is
V
to
is
I is
proportional to I and R is constant. Yeah.
v by
You
I
just
is
misspelled it.
I was saying that V by I ratio does not remain constant in a case
Yeah.
of semiconductors, because as you already mentioned, the changing temperature is different for semiconductor, the changing temperature and then resistance relations. So I would like to ask now, Kiran brother, how would you have explained if it has been asked in interview to you?
Is it because of doping? Because of that, the it is not applicable or something like means like
It
Ohm's
because
law.
it is because of the material property. you must have heard
Hmm.
about two things: ohmic conductor, non-ohmic conductor. Ohmic conductor are copper and iron. Okay, a non-ohmic conductor are semiconductor devices like diodes and the electrical components like capacitors and all. They don't follow
Okay,
Ohm's
okay.
law at all. Okay, capacitor,
Okay.
inductor. Okay, so
Okay.
going with Kiran brother.
Hello.
Yes.
So basically, Ohm's law is only applicable for the ohmic conductor itself, and Ohm's law is not applicable for the semiconductor because it adds the variety of temperature. Cause the current, suppose if the temperature increases, the flow of current decreases or increases inside the semiconductor over there. So for that reason, somehow the Ohm's law is not applicable for the semiconductor. What I know.
Okay. Uh, any application
So it
of
is
Ohm's law?
applicable for only and only ohmic conductor,
Okay.
a transformer.
Okay. Any practical application of Ohm's law? You remember?
Transformer, I say a transformer.
Okay, transformer. And any exception of Ohm's law?
Exceptions of Ohm's law. Suppose the current flowing from the semiconductor from point A to point B.
No, no, no. It does not follow at all. But the something is follow, but does not follow. Like the light bulb filament does violate Ohm's law because on increasing current, the temperature increases in filament. That's why.
Increases.
I just read today that the light bulb filament violates Ohm's law because on increasing temperature, in which the temperature rises as the current is increased. Okay, in this case, Ohm law cannot be applied. Okay.
That would GAN, that's not just for any tungsten or light bulb. It could be for any metal, because as you increase temperature, the electrons begin to freely move and vibrate. So it's very difficult to provide energy to keep them flowing in one direction. So as the temperature increases, for any ohmic conductor or non-ohmic conductor, it will not follow the Ohm's law. Also to be noted that we have special type of conductors for high temperature applications, which are called high temperature superconductors.
Or
And we
maybe
also have for low temperature applications.
but this much idea we are having and we are going only this. Okay, exception I have just read from a valid article.
Yeah,
From
but the exception should also include ohmic conductors,
light bulb.
not just a light bulb.
Not,
It could be for any conductor.
Actually, in reality, or like in practical sense, if you are like applying voltage to a conductor,
okay.
Because of its resistivity, there will be some change in its temperature. For some metals, it's very less, and for some metals, it's very high. So there will be always a little bit of variation between theoretically and practical values.
Yeah, correct.
So,
So
I
as you
think
said,
if you would have
ideal,
done that experiment in 10th, I think 9th or 10th, you might have seen that voltage and current are proportional only for a certain time. If you run the
yeah,
conductor experiment for a long time, the graph
right,
begins to deviate.
because the temperature
Yeah.
increases and
Yeah.
Ohm's law like
we are
disqualifies.
we are
Because
talking on a
idea,
theoretical basis. Yeah.
ah,
Okay. So I would like to add.
no, about what you said about the light bulb filament now, that applies
Yeah.
to every instrument. It just the temperature, like what we know, what we call that property,
Uh, property, which property, like temperature, uh, and
like a variation of temperature based on the resistance.
Resistivity.
resistivity. Variation
Yeah,
of
as
temperature.
temperature increases, resistivity increases after some time for almost everything.
Everyone mentioned like everything, but I want to add one application, one two application of Ohm's law is. First is that simple. It is used for to measure voltage, resistance, and current in electrical circuit. And Ohm's law is also used in DC emitter and other DC shunts to divert the current. Okay, divert the current direction of current. It's for remember purpose only. Okay.
Can you
Okay.
repeat again?
Ohm's law is also used in DC emitter. DC emitter used for current, measuring current, and other DC shunts. You know what is DC shunts?
The devices
DC,
which get connected in series.
yeah, for what? Anyone having idea what is DC shunts?
To limit the current.
Yeah, let me explain. DC shunt is a type of is a specific type of resistor that provides a mini voltage to the output to the emitter. Okay, DC shunt is in DC emitter only. It provides millivolt output.
Yeah, we
It's
draw that in a circuit diagram along with that.
Yeah, some internal
we draw that resistance.
Yeah,
Yeah.
some
IR
internal
is the decision, right?
Yeah. Okay. So the question was if I have to ask limitation of Ohm's law, then we have already discussed it does not apply through Ohm's law is not applicable for unilateral electric elements like diodes and transistor, as they allow the current to flow through only in one direction. Okay, so that's why it's not applicable. And for non-linear electrical elements with parameters like capacitance, resistance, etc., won't be constant. V by I ratio won't be constant to a certain time, so it's difficult to use Ohm law there. You people get it?
Yes.
Okay.
Yes.
So I will move with the next question. What is explain Kirchoff's law? Who would like to go first? Am I audible?
There are two Kirchoff law. Okay. Yeah, Kamlesh, go ahead, bro.
So there are two Kirchoff law. First is Kirchoff's current law, and second is Kirchoff's voltage law. So in Kirchoff's current law, at any junction, the total sum of the currents is 0, and in voltage law, summation of all the voltages and
Yeah, सही है.
voltages across all the devices and the EMF is
summation
In a
of all the
closed
voltages
network.
taken in the appropriate direction. Direction याद
In
रखना.
a closed network is 0. Summation of all
Close to
potential
closed.
difference drop. वही बहुत जरूरी है
No,
closed network या फिर closed mesh.
The
what we call
algebraic
that
sum of change in potential around the closed loop is 0.
Yeah.
change in potential, right?
Okay. Which type of conservation of is based? Kirchhoff's law is based on conservation of which energy and conservation of actually Kirchhoff's law is based on conservation of current and energy. That in first concept, first law, Kirchhoff current law, the current entering through a node will be equal to the exiting through a node at junction. Okay, so that is the conservation of current. Now, second, coming to the second law, Kirchhoff voltage law is based on the conservation of energy. Means in a loop, if you go through the voltage, sum of the voltage drop will be equal to the 0. Would I
The direction.
like the algebraic sum of every voltage in the loop
Voltage
is equal?
Yeah.
Algebraic sum of
in
every
in
voltage.
more
सही है भाई सही है.
sorry.
Yeah. The algebraic sum of every voltage in the loop has equal to 0, and this property of Kirchhoff law is called conservation of energy. Okay. So it is basically a pair of law that deals with the conservation of current and energy in the electrical circuit. The first one is Kirchhoff current law. The second one is Kirchhoff voltage law. Okay.
In case of voltage law, we also can say that the voltage supplied is equal to voltage consumed. Can we say that?
Voltage supplied is equal to voltage it is the same.
I mean, let's say if like voltage summation of all the voltages supplied is equal to summation of all the voltages that drop in like let's say there is a resistance connected in series. So across that potential difference will drop, right?
Yeah,
If you apply voltage
it's as if you are not mentioning algebraic sum, then you can say. When you are
yeah, I mean
mentioning,
in like simpler terms, you can say this.
okay, yeah, yeah, because the energy supplied is positive, the energy consumed is negative. No, yeah, voltage drop is negative.
Yeah, yeah, yeah.
Is equal to equal to. Am I visible to everyone?
Yeah.
Guys,
Yes.
you can say.
Yes.
Okay.
Yes.
Yeah. Now coming to the third question, explain Faraday's law.
Yeah, I would like to explain that.
Yeah, go
So
ahead.
basically, Faraday's gives the two laws. Yes. So basically, Faraday's gives the two laws about the electromagnetic induction. So Faraday's first law gives the information about how EMF is induced. So it states that whenever a changing magnetic field is linked or associated with a conductor, an EMF is induced in that conductor, and when conductor forms a closed coil, the induced current because of that induced EMF flow through it. And Faraday's second law gives the information about the magnitude of the induced EMF. So it states that the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. That is, E is directly proportional to the delta phi by delta t, where delta phi is equals to change in that flux with respect to time, that is the delta t, and that is.
And what is
And
N?
E means the EMF.
And what is
N
the
means the number
formula?
of turns.
What is the
Number
formula?
of turns.
What is the formula for Faraday's second law?
E is directly, yes.
What is the formula? What
E
is
is
the
directly proposed to the minus. I saying E is directly proposed to the minus delta phi by delta t, or minus nr in mod delta phi by delta t. N
E
means
is
the
equal?
number of turns, minus because of the Lenz law.
Yeah, correct. Okay, we'll go through the Lenz law. I have
Why it is minus?
yeah.
Yes.
Because
My
of the
Why
Lenz
negative
law.
sign?
so,
So direction of induced train is directly proportional to the so it is minus because of the direction. It says that the induced EMF always opposes the magnetic field, so it creates its own magnetic field and it's changing its direction.
the
It's
negative
opposing
sign.
So
its
it tries to
direction.
reduce
Yeah.
its magnitude.
The negative
Yes.
sign, just you said, the negative sign indicates that the direction of induced EMF is the change in direction of magnetic
Is
flux
Opposite.
opposite sign.
always
It's opposing.
tends to opposite.
Simply if the magnitude, if the EMF induced or flowing to is a clockwise direction, so that it is rotated in the anti-clockwise direction, so it opposes it, so it like the Tom and Jerry race.
Okay. So now I will ask, what is EMF?
Electromotive force.
So EMF means the electromotive force. So basically this force is applied on a current. Because of that, the current is flowing from one point to the another point because of the voltage.
Electron.
Okay.
Like I can say energy and work done. Energy is EMF and work done is current. If we
No. I said that we know that the current flow from one point to the another point. So basically the current flow because of that EMF. So EMF is the force acting on the current which leads to travel the current from one point to the another point.
Yeah, same. I was saying that
right.
if we apply analogy of work done and energy, like I am having energy of 5 joule, then I am having capacity to do work of 5 joule. Okay, so if I am having EMF of 5 volt, so I can travel like I can produce a current of 5 ampere and 1 ohm, V equal to IR. Unit of EMF is what?
Volts.
What is unit of EMF? Volts. Okay.
Volts. Actually, Kiran, I would like to just correct it. The
Yes,
EMF
yes.
is force acting on the electrons, not on the current.
Which okay.
Okay,
I
so
get it. So
electrons are moving from negative to positive, and as a result, we
Okay.
say the current is flowing from the positive to negative.
But
Flowing. Okay, okay.
But I have read today that it is the energy that causes current to flow. What's wrong with this through a
We
circuit?
can also say that. No, we can
Both
also
are
say that.
same.
But
There is
basically,
nothing
current.
wrong
So
with it.
basically, current means the motion of the molecules or motion of the electron from one point to the another point. So it's most correct as Kamlesh said.
Yeah, but you can like current is
On point.
yeah. Okay, let's just keep it aside. As again, as you said, there is nothing wrong. Like, EMF is energy actually. I'm also getting confused. Actually, see energy. Anyone please
It is the energy that causes current to flow. That's why it's measured in
Yeah,
volts.
Yes,
Now,
So
that's why it is
electromotive
measured in
force
volts.
means the force.
Yeah. The if anyone else who would like to explain the Faraday's law of electromagnetic induction in their own way,
yes.
yeah,
Again,
go ahead.
according to Faraday's law of electromagnetic induction, whenever there is change in magnetic flux associated with the closed loop of conductor, there will be EMF produced in that conductor, and the magnitude of that induced EMF is directly proportional to the rate of change of magnetic flux with respect to time.
Correct. There is consist of two laws. First law tells about the induction of EMF. The second is quantifies how much EMF is produced. Okay. Anyone else who would like to explain their answer? If he had been asked in interview, how would have they have answered this? Like we are just practicing how
Okay,
to
okay,
answer.
okay. Okay, there are two laws of electromagnetism. Faraday's law of electromagnetism. The first one is when I क्या हो गया भाई क्यों हंस रहे हो?
Your profile is good. Okay. Yeah.
Okay.
Go ahead.
When a current carrying conductor is placed in a varying magnetic field, an electromagnetic force is induced in it. So such that the induced EMF will generate the induced current. No. Okay,
No.
okay.
You are right.
Wait.
Induced EMF moving with the closed circuit.
Because of the induced EMF and induced current will be current will be induced in the circuit.
Further, take up pros and try again.
Okay, wait. When a current carrying conductor is placed in a varying magnetic field, electromotive force, that is EMF, is induced such that if the conductor circuit is closed, so that a current is induced, which is called as induced current.
And what about the second law?
The Faraday it states that the induced voltage by changing magnetic field is equal to the rate of change of flux in the circuit.
Induced EMF. You said voltage.
Both are same, na?
Both are
But
same.
beware of saying, like, even if mathematically when you are calculating, you treat them as same, but they are actually two different stuff. Potential difference is the energy.
Unit is in volts, na, so we can say it's as a volts. No problem with that.
Okay. And I have one cross question. What if the conductor circuit is not closed?
Current is flowing.
Hmm.
You answer that question. So then how we can take the reading? Means how we can taking the output?
It will be short, like
So
it
for
will
the
be
output
open.
required,
Yeah.
the
so because
current
of
will
the
not
getting the
flow.
direction, we know that.
Yeah. Correct.
If it's not closed, the current will not flow.
Yeah. Okay. So I
So
will
can we
go.
say that if it is not flow, it's not flow, there would be presence of any current. Sorry, there is no current in the circuit. That's why we can say that no EMF is being generated, right?
Yeah. If it is
Then
not
you're on
flowing.
your
No, the EMF is generated, but the current is not flowing.
okay.
Now we're coming to the Lenz law. As we already discussed that the negative sign that it tells the direction. Anything else about Lenz law?
I have the next explanation. So, like, I would like to add something. So, the that magnetic field is induced because of that changing magnetic flux. Firstly, say that I am. So, cause if the number of the lines of that magnetic field cutting the conductor is changing, that causes the changing in magnetic field.
Correct.
So the direction of induced EMF is such that it opposes the magnetic field. That means the induced EMF tried to flow in that opposite direction as the current flow, as the magnetic field flow. So it's the same.
Yeah. Suppose this is a magnetic field. This is the coil. There is going, and there will be generation of magnetic field opposite to that coil. Like if there is north, there will be also generation of north pole that will oppose. Correct?
Yes, 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 yes.
Okay. So on
I
which
think
thing
it
it
will
is
be
based
like
on?
thumb rule.
I haven't heard of, like, which type of conservation is this?
It's conservation of energy. See, the magnetic field has to be
Uh,
zero, right?
okay.
Now you
So,
gave an example of a coil. Okay.
correct.
So
Correct.
you basically said that the magnetic field will go through the coil. The direction of current induced in the coil will be such that it will induce a magnetic field according to the thumb rule. If you wrap your palm around the conductor, the thumb is facing the direction of the conductor. Then
Correct.
your fingers will indicate the direction of the magnetic field. The direction of the magnetic field will be such that it will try to cancel out the original magnetic field, and
Correct.
that is because of the EMF being induced. So that's how.
Like current is like this in clockwise direction, then this will be the direction, and here is the magnetic bar. Yeah, opposing force.
No, the thumb will be the direction of the current. Your thumb will be the direction of the current. Yeah,
Let it go.
and your fingers
Like
will
this.
wrap around the conductor. Yeah.
Like
Like the statement is like, imagine if you are holding like current carrying conductor in your hand.
okay.
Your thumb is pointing towards the direction of current. Then your
Okay.
curved fingers will give the direction of magnetic flux around the conductor.
Like current carrying conductor will be the in direction this. There will be
Yes.
magnetic flux will be direction clockwise.
Yeah.
If current is flowing
Yeah,
like this,
that's-
there will be clockwise direction. Okay, correct. So we'll go with the next
called as
question.
right hand screw.
Just
But before
just
going
say
that,
that the FBI, if you stretch your finger 90 degrees with each other, then just say the FBI. FBI, like the F means
right
F
or
means
left,
use the thumb, that is
right
the
or
EMF,
left,
and left, left, left,
left.
left, left, left.
Okay.
FBI. Like
F
F means the EMF, B means magnetic flux, and I means the current.
current. I, but the thumb will be the
That's
current now.
Fleming's rule.
We'll discuss
It's
in
EMF.
Both are different roles. This one.
it's different.
We are talking about
I says that left hand rule.
Yeah, you are saying left and right hand rules. So B is magnetic field, I is the forefinger is magnetic field, middle finger is current, and F is force being applied on the current.
Yes, yes, EMF.
And what is the Lenz law application? What are the Lenz law applications? Anyone know?
Lenz law is
Can you think like induction motor, then generator?
Yeah, generator is the correct option. AC generator. AC generator.
Transformers?
Transformer is not given in the options. Yeah, AC generator. No, transformer is not in option. I am reading options.
No. Hello.
Yeah.
Hello. The most wrong answer here is a transformer. Because transformer is a static device simply. Negative. Wrong answer here.
No.
Transformer is a
Even if
static device.
is static
There is
device,
no rotating part over there.
listen to even if transformer is static device, there will be change of magnetic flux. right? First thing. Second thing,
Because yes.
there will be induced EMF. That's why there will be application of Lenz law. Fleming's left and right hand rule won't be applicable for transformers.
Dutch transformer
But
follows
Lenz
Lenz
law
law.
and Faraday's law will be applicable.
Transformer follow.
According to me,
Obviously,
Lenz
it will
law
be, because there
not
will be
possible.
induced current.
Let me see. Does magnetic induction in
According
a
to me, it
transformer
not
is
follow
governed by
that.
yeah, Kamlesh bro is right. Magnetic induction in transformer is
I
governed
think
by
Kiran, you
Lenz
are
law.
getting a bit confused about left hand rules.
Yeah. Is governed by Lenz law and Faraday's law.
You are getting a bit confused in Fleming's rule and Lenz law.
That magnetic induction in transformer now will be governed by Lenz
So
law.
see, whenever there is induction, whenever
Yes,
there
get
is
it.
something current is induced, there will be Faraday's law and Lenz law will be in action.
That's why current output current input current decrease or increase by transformer based on this law.
No,
Current is
that's because of the number of turns.
number of turns.
Yes, that because of number of turns on the secondary winding.
Yeah.
Because of the voltage flowing through that number of turns. If the number of turns is more, then more voltage is flowing, and number of turns is less, then less voltage is flowing. That gives us the step one, step down transformer acts like this.
Yeah.
So inductors and transformer wouldn't work if the fundamental laws of electromagnetism didn't exist. We would only have an electric field and no magnetic effects produced by moving currents. Means for producing magnetic effect, if there is magnetic effect producing, is there is induced current producing, then there will be Lenz law, there will be Faraday's law. So the conclusion is transformer applies in Lenz law applies in transformers. I am going to read other options of application of Lenz law. It's eddy current balances in metal detectors, in braking system on trains, eddy current dynamometers, card readers, microphones. These are the examples, are just to remember. We can explain AC generator.
What's the question again?
Lenz law applications. There were some points.